Here are some notes on nuclear notation. A couple things to recognize the notation is that at the very top, this is our mass number. At the bottom, we have the atomic number. This is also that number of protons. Now just a hint, on the periodic table, you may not be given this bottom number, and the notation could look as this. We have 37 and then the chlorine. The reason is the periodic table is available and you can find this information on the table. Now in the next two examples, we have one more number that's very important. This is the charge. And this is the difference between nuclear notation and hyphen notation. Nuclear has a place for the charge. When we have a charged particle, we're going to call it an ion. And when there is no charge, this is our atom. So, two names that we also need to remember when we have an ion is we can have a negative ion, which is an anion, or a negative ion. And then we have what's called a cation. For a cation, remember a positive sign's a plus, very similar to the T in the middle of the name. Now the charge is based on the protons and electron balance. So if there is no charge, that means that protons and electrons are equal. If there is a positive charge, that means we have a loss of electrons, and so there will be more protons than electrons. No, protons cannot change, only electrons can to give us the charge. If it is negative, we have a gaining of electrons. So therefore, we will have more electrons than protons. Again, protons can't change, only electrons can for the charge. For this nuclear notation example, we are going to be using an atom, which means there's no charge. So when we look on our periodic table, that whole number is that atomic number 17, which is also identifying the element, which is our number of protons. With our periodic table, we're also going to be taking a look over here. The decimal number is our 35.45. Remember, this is the average atomic mass. And also you need to make sure to include the unit, gram per mole. Now in our problem, up in this top corner, we also have what's called our mass number. So bring that 37 down here, and that is going to help us identify how many neutrons. Remember, this mass number is always a whole number. To find neutrons, you're going to take your mass number and you're going to subtract the number of protons. So 37 minus 17 will give us 20. With electrons, we have to consider the charge. Since there is nothing up here where our charge spot is, that means our charge is 0. When the charge is 0, protons equal my electrons. So 17 protons means we have 17 electrons. With no charge, my valence electrons, you have to look on the periodic table for. So we go back to chlorine, we go to the top of the column, and we see the number 7. So there are 7 valence electrons. For Lewis dot, we grab that symbol, the Cl, and we put 7 dots around it. Yes, the number of valence electrons matches the number of dots.